Hi everyone, welcome to the third and final video we have for our lab assignment for week 5 of Knies 6770. So in the final example, we're talking about a case study from the textbook, which starts on page 168, in which we're talking about the tuberculosis data from the World Health Organization. So this is actually a pretty massive data set that tracks the incidence of tuberculosis across many different countries over at least 30 plus years. So it's a lot of data that we're working with, and as they talk about in the book, we actually have to go through a number of steps in order to make it tidy. So I'll go through those 5 different processing steps here, and I'll talk about kind of what we're doing all along the way. But the main thing is that we want to make sure that you've run library tidyverse, right, to add all the tidyverse functions and data to your library. And then you can just run the word WHO for World Health Organization in order to access that data frame. We'll have to go through the 5 different steps of tidying the data that are laid out in the book, but then we'll be in a position to answer question 4, which is on page 168. And that is, for each country, year, and sex, compute the total number of cases of TB. And they want you to make an informative visualization of the data using ggplot2. In addition to that, I've added 2 sub-questions where I want you to restrict it only to North American countries, and then I give you a list of North American countries as their names appear in the WHO data set. And I want you to create an actual table showing the total number of TB cases over time as a function of gender. And then you can insert that table below. Then, in the final part, I want you to actually create a new plot, identical to the one you created before, but again, using only these North American countries. So it should essentially be a subset of what we plotted originally, but in our final figure, we're going to focus only on those North American countries that we put in up here. So coming back into our R session, right, we have this header for a case study using the World Health Organization's data. First, we'll need to actually look at what these WHO data look like. And it is a pretty massive data frame where we have countries, we have ISO2, ISO3 as variables, we have the year as a variable, so this tracks the year inside of each country. And then we have these codes, which are new SPM014, new SPM1524, and then a whole bunch of columns that have similar labels. And as we'll see, these columns are actually sort of complex, non-tidy information that tell us something about the observations within each country and who is contributing those observations. So the first thing that we're going to do is gather this data together. Okay, so we're going to take this WHO data, we're going to push it through a pipe using gather. And so we're going to gather across these variables from new SPM014, right, which is our first column here, all the way to new rel underscore F65, which is actually the last column that we would have if we printed everything to the screen. We're then going to have a key, and the value is going to be called cases. So in order to do this, we can run the code from the book and look at what this data looks like now. Okay, so we have then taken those variables, which were previously represented as columns, and we have taken those column names and turned them into our key. So you can see in each country, I mean, we can only see Afghanistan at the moment, but in each of these countries, in each year, we will now have a variable, which is our key, where each entry for that variable is previously a column name, right? So this one is not, the first one here was new underscore SP underscore M014. And so we see then for Afghanistan in 1997, for new SP M014, there were 0 cases. For Afghanistan in 1998, for new SPM014, there were 30 cases of tuberculosis, and so on and so forth. So the next thing that we want to do when we process this data is we're going to have to mutate this key variable to create a new version of the key variable. So what we're going to do is take WHO1, right, which is our gathered data frame, push it through a pipe into the mutate function. We're going to overwrite the variable called key using the string replace function. And in the original key, we will replace what used to be new rel with new underscore rel. So we're going to put an underscore between these two terms. And then we can look at the head of this data frame. And the first part of this looks exactly the same because we didn't actually mess with new underscore sp underscore m014. All we did was add this underscore into the new rel command. From there now, what we can actually do is use the separate function to break this key variable apart into its constituent components. And it's here I really want to clarify, and they do slightly talk about in the book, that we wouldn't know necessarily how to do this or what these variables are without the code that's already provided for you. And that's why that's provided for you in the book. So if you're looking at this and you feel like, I don't know how to do this, that's kind of expected. These are more sophisticated data processing steps that really haven't been introduced at this point or explained in great detail, but we need to go through them in order to arrive at the tidy data that we want at the end. So if you felt a little lost in these processing steps, that's totally okay, but that's why I really wanted to talk through them now, and I hope as you're reading back through the book, you can get a better sense of what's actually happening to our data set each time we push it through these different tidying steps. So now that we've added an underscore to this new underscore rel value in the key variable, we're going to take our who2 data set and we're going to push it through a pipe into the separate function. And what we're going to want to use the separate function for is to take each of these key values and separate them based on the underscore. So what we're going to get is we're going to take that variable, which was called key, we're going to separate it into 3 new columns. We're going to separate it into one column called new, one column called type, and one column called sex age, which is a combined value across those two, the last few characters of that string. And we are going to tell the function that the separator is an underscore. So that means that it's going to look at this and it'll look to the left of, it'll look at this first underscore, it'll take everything to the left of it, put it in the new column, it'll take everything to the right of it, put it in the type column, and then it'll look at this next underscore and everything to the right of that, it'll put in the sex age column. So when I push who2 through that separate function, in order to get the header for who3, you can see that my key column has been replaced by 3 different columns, which now individually represent all of those pieces of information that used to be in the name of the sex age variable. So I now have new, type, and sex age as a combined variable. I can then actually count the number of new observations there with who3. And what I'm ultimately going to want to do is drop some of these columns from my data frame because they're not going to be super critical to what it is that we're trying to do. Okay, so we're going to take who3 and we're going to push it through select. And we'll use the negative sign to indicate negation here. So we will be dropping the new column. We'll be dropping ISO 2, and we'll be dropping ISO 3. And we'll push who3 through the pipe in order to drop those columns. And what we are left with is a slightly truncated version where who4 now tells us the country, the year, the type, the combined sex and age are still in one column. So we're going to want to fix that. But then we have the number of tuberculosis cases in each year there. So in order to split sex and age apart, we can run through another separate function, right? Because first we separated based on the underscore, and now all we're going to want to do is split this information apart into the first character, which is either an M or an F for male or female, and then the last characters, which tell us about the age of those cases. So what we're going to look at then is taking who4, pushing it through the pipe to separate sex age and creating 2 new columns called sex and age, where we're separating it after the first character. And when we do that, we finally have what we want, right? Which is we have the by country, by year, we have the sexes and age ranges of various individuals, and then we have the number of cases in that age range for that sex, for that year, for that country. So this is a really, really large data set, right? Like if you look at WHO5 up here in our global environment, there's actually 76,046 observations of 6 variables. So we have the data in a tidy format, and what we're going to want to do, though, is actually reduce this down even a little bit further. And I have the code to do that in sort of one step here, combined with the code in order to make a ggplot. So I'm going to talk you through the pipeline that I've created in order to summarize that code and then produce the ggplot that we want. So we're going to take WHO5, we're going to push it through a pipe into the group by function, right? And now we know, based on the question, that we're going to want to look at these data as a function of country, year, and sex. So I want to group by those variables. I'm then going to filter these to only look at data after 1995. And I'm going to show you why I want to do that in a second. But within each country, year, and sex, then, we are going to summarize cases by taking the sum of all cases. So what that means is, for each country, in each year, and each sex, we are then going to add up all the cases regardless of age range. So we don't care which age bracket these cases fell into. We just want to add all of them together to get the total number of cases per country, per year, per gender. So that's how we can use this group by and summarize together in order to do that calculation. I'm also going to calculate a new variable using the unite function. So in order to make a plot that's a little more cohesive, I'm going to combine the country and sex variables into a variable called country underscore sex. And so I will say unite, create a new variable called country and underscore sex, which combines country and sex. And then we'll say remove equals false. And then I'm going to push all of that, now that transformed data, into my ggplot function, where on the x-axis I'm going to have the year, on the y-axis I'm going to have the cases, and then I am going to group them by both country and sex, where the color of the lines that I draw are based on the category of sex. So if I run that code, you can see I get a plot that looks something like this. So I have my cases on the y-axis, the year on the x-axis, and I have a whole bunch of overlapping lines which are grouped by country, right? So I have individual lines for each country, and then the color of those lines is determined by the sex of the cases in that country. Now, the reason I filtered this from 1995 onward is because if we turn off that filter and rerun the same code, you can see that I have data going all the way back to 1980, but the data were incompletely collected until about 1995. And so we're actually missing data for a lot of our countries from before 1995. So when you initially created a plot, it might have looked something more like this. And that's totally okay. We actually see more of the data this way. But in terms of creating an informative plot, or indeed in terms of analyzing the data, we might actually want to start from a point where more of our data were available. So in that case, I'm filtering from 1995 onward in order to generate a plot that looks a little something like this. So this would be the plot that you need to create in order to answer question number 4 from the chapter. However, I went a step further and I asked you to do some additional steps specifically to look at the data from North America. So I gave you the names of the countries as they appear in this particular data set. And one of the things I first wanted to do was create set country to being a factor variable so that I can show you just how many total countries there are in this data set. And if we look at this, you can see there are a lot of countries, starting with Afghanistan and Albania. And then we have about 34 observations per country, more or less. And eventually our list gets down to Kazakhstan. And then it stops and it just says other. And then there are 3,874 observations coming from other countries. So we have a lot of other countries in this data set. And so restricting it to North America will make it a little more focused, a little bit easier for us to see some of the data we might want to work with. So to do that, I'm going to create a new data frame called North America, where I'm going to take my tidy data frame, which is WHO5, I'm going to push it through a pipe, and then I'm going to give it a pretty lengthy filter command because I'm going to say filter where country equals either Antigua and Barbuda, or, right, country equals Bahamas, or country equals Barbados, right? And essentially, I will use a whole bunch of OR commands together, asking it to filter out any data that do not come from these North American countries. So in this way, we will only keep the data from the North American countries. Now, there are more elegant ways you could do this with like a string of country names that you give to the filter command, but I think this is the clearest way in which you could brute force it, right? To just say, okay, I want it when it's this country, or this country, or this country, or this country. So if your list is longer, there are certainly more elegant solutions, but I think this is a way that reinforces in relatively simple terms how you can use the filter function to actually select a lot of different types of data to ultimately isolate it down to the data that you want. So if I run that and I push Who5 through my pipe into my filter, I'm ultimately going to end up with a North American data set. Again, I'll turn country into a factor because it will be a character vector after doing the filtering. And then I can get a summary of the data in the North American countries. So you can see that for Antigua and Barbuda, I have 346, for Barbados, 318, right, for Canada, 672. So I have now numbers of observations for each country in my North American data set. And if I look at the head of the North American countries, right, you can see that now rather than Afghanistan, my list starts with Antigua and Barbuda, and it starts in 1996. We didn't have any cases in the 14-year-old males range in that year. Okay, so we've successfully isolated this down into our North American countries. If I now want to get a table that summarizes the incidence rate in each of these countries by year, what I can do is I can print the result of pushing the North American data frame through a pipe where I select just country, year, sex, and cases, right? So I'm going to ignore type and age, push that result through a group by function where I say group it by country and sex, because again, I want to ignore age range and I want to ignore year. I just want to know the total number of cases in each country for each sex over this whole range. And then I will summarize that to get the total number of cases. And if I run that command, you will see that I get a number of, let's see, so here's my two rows for Antigua and Barbuda, right? 2 rows for the Bahamas, 2 rows for Barbados. I'm getting all of my cases for each country in my data set. Now, when you run this command initially, you will probably get a shorter output than I got, because by default, when you print a tibble, it's going to cut it off after 100 rows. Now, there's a couple different ways you could change that. You could specify n rows in the print function, but I think that doesn't actually work with tibbles anymore. That works for other types of data frames, but not with tibbles. So I think you'll actually have to say options, tibble.print, and then adjust the max. So I just set it to 100. And then I set the minimum to 10. So if you change the tibble print options, you can then tell R, okay, when you print a tibble, I want you to print up to 100 rows rather than just up to 10. So if you run that code and then go back and run your print function, you should get all of the elements printed to the screen, and then you can effectively just copy and paste this into Word in order to answer that question and show the table for each country and the incidence rate, or sorry, the number of cases of TB in each of those countries in North America. Finally, if I wanted to create a figure to show this, right, I can actually take exactly the same code that I used above when I was looking at all of the international data, but now rather than Who5, I can just push my North American data through my group by function, through my filter function, through my summarize function, create a new variable, and then ultimately create a ggplot, which when I get that, now you can see I have a slightly simplified version of the figure that I had before, where I have a smaller number of lines because now naturally I'm only looking at those countries in North America. I can then click on export, copy to clipboard, and paste this figure into Word in order to answer that final question in the assignment.